Good morning, everyone. This is KP the Math G here, and we're looking at the 2025 free response question number 4, part C. That's what we're looking at. Now, from the last video, I just want you to see that this, I'm going to walk up to the camera. This is the real picture. It is drawn to scale. Alright, semicircle, 2 semicircles and a straight line segment. Well, obviously this picture I've got drawn here is not drawn to scale. It shows something that looks like a parabola, doesn't it? But it's not. Evidently this distance from here to here is about the same as this distance from here to here, although this distance from here to here goes to 6 or -6, and this one goes to 3, and likewise here. Well, at least I have the distances here looking almost the same, but that's free-handed, and I know I could probably do a better job than that as far as drawing this picture. But anyway, there it is. I probably could have moved this -3 up here and made a little more semicircle right here, but I wanted you to be able to see. Well, anyway, it could have looked better. Okay. That's okay. Well, these are semicircles, and this is a straight line. Now, part C says this. We'll go find 2 parts. So let's see, find, alright, I want to say it's going to be G at 12, and I want to say the other one is G at 0. They're testing they're testing your ability. When you're saying find G of something, anytime you see that and you see this is looking for the area. Can you find the area of, say, a semicircle? Well, you have to know that formula, don't you? Alright, A is equal to 1/2 pi r squared. Okay? This is always going to be in the form of a triangle, so the area of a triangle. And if you're saying 1/2 the base times the height, you are absolutely right. They're testing you on that. Do you know area? Do you know the area of, say, a trapezoid? Do you know the area of a circle? Okay, and so on and so forth. Do you know the area of a triangle, a semicircle? Stuff like that. And do you know how to integrate using this area right here? Okay, so G at 12. Okay, you're just going to use this form right here. You got the 6 already given to you. Alright, F at T dt. Alright. Don't worry about the T. Alright, really don't worry about that. Just worry about doing this from 6 to 12. This area here is what's under consideration. Alright, this is the area. Alright, from 6 to 12. So the area is 1/2 the base times the height. So 1/2. Let me get another marker. 1/2. Apologize. You know what? I'm just going to erase that and do it again. Now, 1/2 the base from 12 to 6. 12 minus 6 is 6. The height is 3. Alright, so 3. 6 times 3 is 18. Half of 18 is 9. So that area is 9. And if you had square units, I don't believe you have to say square units. The area is 9 because they don't give you any units. Now if they gave you this in centimeters, you can say square centimeters. Square centimeters, okay? If you're rotating something about an axis, that's going to be 3D, so that's going to be cubic centimeters, okay? So if you hear a little sound outside the door, that's my wife's phone ringing. So bear with me while we're just kind of working from, my wife's on one side of the door and I'm on the other side of the door. But anyway, it works out. Now that's it. That's all you got to do with this. From 6 to 12. If this had been, I'm just going to go ahead and show you. What if this had been a 0 down here instead of a 6? You would have still went from 0 to 12. Okay, let's do that because this lesson's kind of short anyway. We already know that from 6 to 12 it's 9, right? Let's deal with this. Alright, so from 0 to 6, alright, it's the integral from 0 to 6 L fit T. Ooh, I am so sloppy. L fit T dt plus from 6 to 12 L fit T dt. Well, we knew that was 9. We just figured that out. All that's left for us to do is figure out from 0 to 6. So from 0 to 6, that is pi 1/2 pi r squared. I just told you the formula and then I didn't put the 1/2. 1/2 pi times the radius squared, which the radius is, alright, 3, right? 3. Alright, so the radius from the center is 3. Alright, so 3 squared. 3 squared is 9. So 9 times pi times 1. This is over 1. This is 9 pi over 2. So this would be 9 pi over 2. Like that. Plus 9. So 9 pi over 2 plus 9. If you had to go from 0 to 12. That wasn't one of the problems, but that could very easily have been one of the problems. Let me give you something here. Suppose this had been, and I know I'm going beyond here, negative 6 to 6 L fit T dt. This area, I believe, is the same as this area, but this being below the x-axis and this being above the x-axis, they will cancel out and that answer would be 0. Okay, well, alright, let's go ahead and look at the problem at hand. That's the one that you're really wanting to do. So this is going to be from 6 to 0. They want to test here, do you understand rules of integration? When the bottom number is smaller than the top number, then you remember you can make it where the bottom number is smaller, but you have to put a negative sign on the outside, L fit T dt. They want to test to see if you know that. So remember, put this negative sign out in front. You cannot just leave it like this and just find the area. we found this area, didn't we? But we already know 1/2 pi r squared. So 1/2 pi times 3 squared, and that's 9. So that's actually 9 pi over 2. But remember, that's a negative. All right, so a negative 9 pi over 2 would be what you would get for that one. Okay, so just kind of keep that in mind. That is a negative 9 pi over 2 right there. Alright, so that is that's what you have. Alright, and that's why this is negative here. And for one thing, it's below the x-axis. Usually that's going to be negative like that when you see that. But they did this 6 on purpose down here so that when you put the 0 up here, you automatically put the negative sign in front just like that. Alright, so anytime, it doesn't matter what it is, I'm just going to make up something. Anytime you're going, say, from 5 to 0, or, it doesn't matter, let's say -1, f at t dt, then you just simply put the negative out there in front and say -1 to 5 f at t dt. Alright, so that's how you do that. Just make sure you flip those over like that. Alright. I want to say those are probably limits of integration. I think that's what you call that. It's been a while since I've taught the class, but I think those are called limits of integration. If somebody won't tell me differently, please correct me. Alright, so that's kind of what I wanted to deal with on this one. It's a very short lesson, but needless to say, you may have one like that either on the multiple choice or on something like this where you have to find, something like that. Alright. I will shortly do the last one. I like part D. It's very important that we understand all of this, but especially how to do that part D, which I'm going to show you in the next video. Needless to say, this is KP the Math G. If you have not subscribed, you can subscribe if you would like to. That's just optional if you'd like to. If you like to hit that like button, I always smile when I say that, I like a like. If you like to make a comment, please do so. I've had a few comments and it seemed like every one of them's been good, or keep up the good work, or something like thank you for showing that to me. I understand this better, or something like this. That really thrills my soul to hear those kinds of comments. You see that I don't have anything fancy that you just come up. All this can come up so nice and pretty. I wish I did, but I don't. But I'm happy to have the whiteboard, which I want to say my wife got for my birthday, I think, one day. Birthday or Christmas, I can't remember which one it was. But she got it. I think she did. Or did I buy it? Anyway, it doesn't matter. I'm going to give her the credit, okay, since I've already started with that. This is a beautiful whiteboard. I think I remember now. I did choose the size, okay, and I think she did purchase it for me. Okay, so it's been a long time since I've had this up. This has been up for a while, and I thoroughly enjoy it. So anyway, this picture you see right up here is my first grandson. Since this picture now, we've got my son has been has 2 other children, or actually one a girl, and then now a boy coming. I think a boy coming on the way, and then my daughter has a son. So I need to update my pictures here, but I don't want to run out of, you know, whiteboard space here putting up grandchildren pictures. But they're a blessing to me, and my children are a blessing to me, and you're a blessing to me. So thank you so much for tuning in. This is KP the Math G signing off. Ladies and gentlemen, have a great day. Let me try that again. That needs to sound a little louder. That's my signature clap. Signature has to be loud. Let's try it again. Ow, that hurt. That's a little better. Okay. Very good.